daytime fireball was observed across the northeastern United States and Canada. According to the American Meteor Society, 86 witness reports were submitted from locations across multiple U.S. states, Ontario, and Quebec. NASA has since published an analysis of the event through its Meteorite Falls program, identifying it as the Cape Cod Bay, Massachusetts event from May 30th, 2026. Hello everyone, and welcome back to Tech AI Space Oh My. I'm Dr. Amanda Fetch, aka Dr. Amanda Analytics, and I focus on artificial intelligence, space technology, and space situational awareness. Now let's look at the data. We'll start with the American Meteor Society event database. This map shows the geographic distribution of the 86 witness reports associated with the event. Reports extend across a large portion of the northeastern United States and Canada, demonstrating the scale and visibility of the fireball. The next source comes directly from the NASA's Meteorite Falls program. According to NASA, the object entered the Earth's atmosphere and fragmented at a relatively high altitude of approximately 50 kilometers. NASA also notes that this was a daytime bolide, visible across a wide region of the Northeast. This event page includes NASA's meteorite fall analysis, estimated fall location, and radar-based reconstruction. Now let's look at the trajectory model. In this visualization, NASA displays modeled flight paths for meteorites of different masses. The labels range from fractions of a gram to several kilograms, illustrating how fragment mass affects the final trajectory and landing location. NASA states the signatures of falling meteorites were identified using 4 radar systems: KBOX in Boston, Massachusetts, TBOS at Boston Logan Airport, KOKX on Long Island, New York, and KENX in Albany, New York. The labeled markers shown in the figure correspond to radar observations used during the analysis. NASA combined those observations with a physics-based dark flight model to estimate where surviving fragments may have landed. Now, when we examine the model, the projected trajectories converge into a relatively small region of Cape Cod Bay. According to NASA, meteorite fragments may have survived atmospheric entry and reached this area. NASA also notes that the estimated fall zone is approximately 34 meters, or about 100 feet deep, making recovery efforts significantly more challenging than a typical land-based meteorite fall. Now, what I find interesting from a space situational awareness standpoint is the integration of multiple data sources. We have public observations, radar detections, and physics-based modeling were combined to reconstruct an event that lasted only a few seconds and estimate a potential meteorite fall zone. Now, with that being said, I'd be interested to hear your thoughts. What stands out most to you in NASA's analysis? Are you more impressed by the radar detections themselves, or by the ability to model a meteorite fall zone using multiple independent observations? Let me know your thoughts in the comments. Thank you again for tuning in. If you enjoyed this analysis, please like, subscribe, and share. I'll see you in the next video. Take care.